Okay, so there's this joke about this brand new psychiatric intern, and he's stationed of all places at an Indian reservation in Arizona. And, well, you know, one of the Indian reservations is for the Hopi and the Arapaho, and the other one's for the Navajo. In comes an orphan boy. Has this horrible dream. He keeps saying, I'm dreaming I'm a wigwam, teepee, teepee, wigwam, teepee, wigwam. The, psychiatrist intern, first day on the job, can't stand it already and just says, it's so simple. You're too tense. Okay, let's get down to business. This whole video is about how arithmetic and math can be made a little easier. One of the first things, if you don't have a calculator and you're doing some multiplying, start with the one that has a shorter, they call it a mantissa, relevant digits. As you can see here, if you do the one that's shorter, you have less steps. And if you're doing percentages and dividing and multiplying, you probably do know percent, per centum, per century, per 100. So if you're creating the percentage, add 2 zeros. If you're converting the percentage back, you get rid of the 2 zeros. And you look for the lowest common denominator. You look for something that mutually divides. And let's see, that first one, we got how many nickels in a dollar? 20. Well, let's see, if there's 20 and you half the nickel, then there'd be twice as many. There's 40. And you have 20% here. You know what that is? 2 tenths. Oh, I cracked myself. Any case, how many of those go to a dollar? 5. Now, if that's true for 20%, 20 cents in a dollar goes 5, then 2% would go in 50 times. Okay, let's say you want 4 40ths. Well, common denominator is obviously 4 here, so you got 1 over 10, that's 1/10, 0.1, 10%, a tenth, a dime. Well, we got 20 100ths. That's 1/5. See, drop the 2 zeros. You got 2 over 10. There it is again, 2 tenths. And that's 0.2 or 20%. And one can go from fractions to decimals and percents back and forth. Nice thing about the fractions, you can handle them, and you don't get those oddball answers like 0.39999 when it should be 0.4. Here's 2/5. Well, that's 0.4, 40%. 1/5, I know I'm going to milk this joke. 2 tenths, 20%. You got 1 3/4. Well, that's a quarter is 25%. 3/4 is 75. So it would be 1.75. And which, of course, is 175%. 1/20th. Well, how many times does 20 go into a dollar? How many nickels go in a dollar? 20 times. And that'd be 0.05 or 5%. 1/500th. Well, if 1/100th is a penny, then 1/500 would be a fifth of that, and that'd be 2 tenths of a penny. How about 9/4? Well, 9/4, 8/4 is 2, another one, 2 1/4, 2.25, and of course that'd be 225%. And of course, calculators do make this a lot less tedious, although sometimes you lose the insight if they're fractions. And many a calculator might have a little menu at the top, if it's especially on a computer, and that little menu will give you various types of calculators, including scientific, programming. You can do various kinds of conversions. I'll stay with a plain calculator, and they sometimes have a little reverse clock showing you a history of your work, so you can go back and retrieve stuff. Many of the buttons are kind of relevant. One thing that's kind of useful, many times you can paste and copy from the display screen. The most relevant button here on this next line is the reciprocal, dividing itself into one. That's useful in a way that saves you the work of having to write down your answer and use it later to divide, because by making it a reciprocal, you've already made it ready to divide to multiply to your next answer. That's a helpful tip. Below here, the percent key is the clear entry, which is just to undo your last typing, whereas under the square root is the clear everything to start over, and then you have a go back key under the square key, and then you have the whole row of various other keys and operators. Some do not have an equal sign, having already presumed you want the answer. They call that RPN, usually found on scientific calculators. Notation comes in various forms. If you divide A by B, sometimes you'd see that written A over B, or in writing it, say, in Excel or a computer language, A /B. The times, sometimes you put an X. Of course, that's confusing if you're using X as a variable. Modern notation just puts them right next to each other, meaning multiply. In Excel and computers, you use an asterisk. Some exponents, the power, is written with a little caret. That's the upward arrow. The square root can be written a couple of ways. The caret to the half power, which is also the squirt, the square root of the amount in the bracket. I should note, and perhaps you've noticed, that while BASIC and other computer programs do not need a complete letter-number combination for various variables, Excel does. It needs a row and a column, a number, and a letter. But still, the rules still work. When you have groups of, say, multiple factors, we're going to look at this in detail, you have to multiply them fully out. And when you divide one fraction into another, you, as you probably know, flip the denominator. So now you multiply instead of divide that fraction if you flip it. Okay, suppose you're laying out a backyard where you want 4 different color combinations. You want to figure out the total amount, and or you're doing some algebra. There's something called the FOIL method: first, outside, inside, last. If that works for you, fine. Or just lay it out in your mind where you realize that you have each one of the lengths. When you're multiplying them together, you're getting the area, and you're just going to work out what the area looks like. Now, in the case of squaring it, the A's times themselves squared, the B's times themselves squared, and then you have 2 times AB, because A times B is the same thing as B times A, and there's 2 of them. I find this is an easier way to do it. Okay, let's do some examples of some of these arithmetic, algebraic, mathematical shortcuts. There's always more than one way. You want 360. You want to know how many 45 degrees there are in an arc. Well, first of all, let's make these easy to get rid of by multiplying times 2. And in doing so, now you get the zeros to drop out. And now you got 9 into 72, 8 times. Okay, let's try another one. 2 3/4. Well, that's 275 over 100. Well, let's see. 25 goes 4 times in 100. And another is 8. 3 more makes 11/4. Okay, you want to figure out how much saving you 20 cents a gallon on a fill-up is. And you do it 4 times a month, 12 times a year. Let's see. 2/10. I won't milk that joke anymore. Oh, yes, I will. Well, let's see. That's a fifth. 5th of 15 is 3. 3 times 4 is 12. 12 times 12 is a gross 144. I got 180, and I want to divide by 2/3. Recall that that's multiplying times 3/2, and 2 goes into 180. It is 90. You get 270. Suppose I wanted to get 80%, and gee, I think that gives me a 20% more that I can buy. We're going to show that's wrong, by the way. You don't add percentages. Let's see. 80% is 20% savings is 4/5. 20% more is 6/5. We get 24 25ths. See, that's not right. With percentages, you take reciprocals. So saving 20% is cost you 4/5. The reciprocal of that is 5/4. You get to buy 25% more, which is correctly 1. Now, here's a killer trick for compounding. Suppose you bought something for $200. You sold it for $800. It doubled twice. That's 2 to the squared, if you like. And you did that across 40 years. What was the compound rate of return? There's a magic number, the number 72 for doubling annually. So if you divide the rate or the years into 72, you get the other, which doubles. Well, if we doubled every 20 years, 40 for the 200 to 800, and the 20 years divided into 72 would give 3.6%. You either take the percent or the years into 72. It gives you the other, which doubles. That's kind of cool. And a killer example of that is the original Superman comic #1, some like in 1938, sold for a dime, became $10 million just a couple of years ago, some 80 years later. Compound rate of return, 27%. Wow.